This is the fourth video in the series dedicated to Bessey shuffle diagrams. As a reminder, a shuffle S is said to be a Bessey shuffle if and only if S preserves or inverts Bessey sequences. Recall the Bessey sequences of order 8 are 1, 0, 0, 1, 0, 1, 1, 0, and its inversion 0, 1, 1, 0, 1, 0, 0, 1. To aid us in interpreting these diagrams, I've indicated here that half of the digits between 1 and 8 have been color-coded red and half have been color-coded black. So we have 1, 4, 6, 7, black, and 2, 3, 5, 8, red. Written in set notation, we get the following. Also, as we will see, there are times when the Bessey sequence is preserved exactly, and we'll show you what that means in just a moment, or it will be converted to what we call an inversion of the sequence. Furthermore, let me emphasize that the Bessey sequence 1, 0, 0, 1, 0, 1, 1, 0 satisfies this first set of conditions, namely, the 1s are in positions 1, 4, 6, 7, and the 0s are in positions 2, 3, 5, 8. The inversion of this sequence results in that relationship reversing. Namely, the 1s are now in positions 2, 3, 5, 8, and the 0s are now in positions 1, 4, 6, 7. The next shuffle in our series is the FARO in shuffle. So let me go ahead and show you how this shuffle works for a packet of 8 cards. So I have here a packet of 8 cards labeled 1 through 8. We will now perform the shuffle. So how the FARO in shuffle works is you go ahead and just fan out the cards, and note that this is the top card here, of course. So what we're going to do is grab the bottom half of the packet. Now for a FARO in, what needs to happen is the top card here needs to go underneath the top card on the left. And we'll do that by having the one on the right lower than the one on the left. And then you just perfectly interlace them. That's all we're doing. That's the FARO in shuffle. So let's take a look at the new ordering of the cards. Okay, so the new ordering will be 5, 1, 6, 2, 7, 3, 8, 4. And so that's what I've written for our Cauchy's 2-line notation of this permutation. 5, 1, 6, 2, 7, 3, 8, 4. Now we can convert that to cycle notation as follows. We see that 1 goes to 5, so I have an arrow to 5. Where does 5 go? 5 goes to 7. 7 over here goes to 8. 8 goes to 4. 4 goes to 2. And then 2 wraps around and goes to 1. So that completes that cycle. So we actually get quite a large cycle, a 6th cycle here. Now for the remaining cards, we get the following. 3 goes to 6. And then 6 goes back to 3. So we get a little 2-cycle, or what is also called a transposition. Now if we color code our numerals, we get the following. We'll get, now remember, 1, 4, 6, 7 are color coded black, and 2, 3, 5, 8 are color coded red. So we get black 1 gets sent to red 5 gets sent to black 7 gets sent to red 8 gets sent to black 4 gets sent to red 2, and then red 2 gets sent over here to black 1. In a similar fashion for the transposition, red 3 gets sent to black 6, which gets sent back to red 3. So we can see here that each value gets sent to a value of the opposite color. And when that happens, inversion has indeed occurred. So as a reminder, inversion occurs when the cards in positions 1, 4, 6, 7 get moved to positions 2, 3, 5, 8 in some assignment. And the cards originally in positions 2, 3, 5, 8 get moved to positions 1, 4, 6, 7. So the way that we describe an inversion is as follows. The set A gets sent to its complement. The complement of A gets sent to A. So if we relate this to Bessey sequences and begin with the Bessey sequence 1001, 0110, this means that once this shuffle is performed, we will get an inversion of this sequence. So why don't we go ahead and quickly demonstrate that. So remember, for the FARO in, you take the bottom half of the packet, and we need to perfectly interlace these so that the top card here goes underneath the top card here. Okay? So the way to do that is to start lower on the right and then just perfectly interlace them. Okay? So we get the following, which should be the inversion of what we started with. Okay? And so now we've gotten the Bessey sequence 0110, 1001 as anticipated. Okay, so let's quickly look at the graph for the FARO in shuffle over here on the left, and you'll recognize this diagram. In fact, we have seen both the inverse of this diagram and an identical version of this diagram. So why don't we quickly remind you of what those were. So as we can readily interpret right from their graphs, the even up jog in which we stack the left pile on top of the right is actually the inverse to the FARO in shuffle. So it's the exact same diagram except for the fact that the arrows are reversed. So what this means then is if we perform the FARO in shuffle followed by an even up jog for which we stack the left pile on top of the right, it will reset the packet to its original order. And vice versa, if we perform the even up jog with left pile placed on top of the right, followed by the FARO in shuffle, that will also reset the packet to its original order. So these two shuffles are indeed inverses of one another. Now that's not the only shuffle to which the FARO in is related. The FARO in shuffle is actually identical to the RC shuffle, in which we deal out the cards into 4 piles, 1, 2, 3, 4, 1, 2, 3, 4. We build up the piles one level at a time, and then we stack the piles from left to right, and that will give you the exact same permutation. And so that's why the graphs actually agree. The FARO in on the top left side of the screen has a Bessey shuffle diagram identical to this RC shuffle in which we're stacking from left to right. Now for those who are new to this series on Bessey shuffle diagrams, why don't we just quickly explain how our permutation gives rise to this particular diagram. So the way that we read this is we begin at 1, so 1's over here, and it gets sent to 5. We can see that up above here. So 1 goes to 5, 5 goes to 7, so here's 5, we're going to go up to 7. 7 right here goes to 8, well 7 goes up to 8, and 8 gets sent to 4, so 8 gets sent down here to 4, and then 4 gets sent to 2, and finally the 2 here gets sent to 1 at the beginning of the cycle. And that completes that 6th cycle. And we say that the values 1, 5, 7, 8, 4, 2 are in the same orbit. They simply get permuted or rearranged among themselves. And then we have a remaining 2 cycle, which is also called a transposition. So we need to go down to 3, and then there's an arrow from 3 to 6, but also Since 6 wraps around to 3, there's an arrow from 6 to 3. And so they just switch back and forth every time that shuffle is performed. And as already noted, inversion of our Bessey sequence occurs.